I'll first introduce BOSCH briefly to you, then be a little bit more specific about CCTV or video systems as it is called, and talk a little bit about the products and our challenges there. I'll explain you why we embarked on critical chain, what is the problem we have to solve. I'll give you a brief overview of when we started and what steps we took so far, then move to what went well, what we have achieved, but also the challenges we encountered. And I can say already, I cannot demonstrate these fantastic results as the HP guys are demonstrating, not yet. Yeah? And I like to finish with looking back and say, if we would start all over again, looking at our company, at our culture, what we have learned, what would be our dream implementation plan? Yeah? And finally, some conclusions. So we are in systems, and some of those products are systems in themselves, are complex systems in themselves. And that brings a lot of variation and the typical critical chain challenges. I want to zoom in a little bit on this embedded digital recorder. And there's a lot of inherent uncertainty in these type of projects. Just to mention a few, you start a complete new development of a digital recorder, and then you get this long list of features, and you start discussing them. What are the consequences? Can we do this? There's real-time performance requirements. Imagine a single box where 16 cameras are being recorded real time. 480 frames per second are compressed there. Of course, there's a lot of functionality, so you have to define the user interface for different kind of users. You have to select your key components. Can they do this? These features, can they meet this performance? There's complex board design, very comparable to what a computer motherboard is doing. Of course, you pack a lot of stuff in one box. So what about the temperature? What about the electromagnetic compatibility? Can we do this? Of course, you have to design a cabinet. There's a huge software effort. There's product cost. Also, this market is very competitive with a lot of Far East competitors. Of course, you need a software architecture. There's different video compression standards. Where are we moving? And we are applying hard disks in these units. So the box in itself is a complex system where you can make many choices, many interactions. Reliability is another requirement. There's the outside world. We connect cameras, and they become network cameras, also from different vendors. There's keyboards for control. There's disk array extensions. There's network equipment, and we don't control the network equipment. When a system is deployed at an airport, they buy their routers, their switches, and they are all different. There's remote software, management, configuration. And of course, the customer expects good performance, but that depends on the network performance. There's also power failures after lightning, and we don't want corrupt data in the unit. You have to be compatible with all kind of old equipment in existing installations. There's obviously competition, and we work close with suppliers. So the bottom line is that this is not something like, okay, we have here requirements, let's do some design, and then implement and test it. Those requirements are being developed all the time. And in parallel, you start developing an architecture, and you start already implementations. But you are continuously asking, is this feasible? Can we do this? And you start already integration, validation, and testing. So there's a lot of related interactive activities. And they are sources for interrupts, because these guys have all these balls in the air. And the inherent uncertainties are also driving Parkinson's law. Let's look a little bit deeper. Let's maybe also look at this alternative. Maybe we should do one more experiment before we are certain. So this is really bringing a lot of additional time. So actually we started applying critical chain in the implementation phase, and I'll show you right what our key problem is. But the deeper we are into it, we start believing that the largest gain in productivity is possibly in this fuzzy front end, where all these technical uncertainties are up. Basically, those of you who are familiar with the capability maturity model, and some of them that are working in contracts for the government, maybe software developments, are forced into that. They recognize such a picture, and CCPM basically provides the flow for all those activities that are required by the capability maturity model. So what was our problem? Basically, what you see here is that we have this concept phase, and then at a certain moment we have a milestone. There is where we say we commit for an end date, like the window in HP, but we don't have these windows, unfortunately, maybe. That's where we are going to spend the big money. That's where we commit the resources. That is where we commit the end date. So we have a planned release date after the implementation. In average, we slip 50%, and that's weighted over the size of the project. So that's damn serious. And that's serious in 3 ways. So let's assume a certain sales level is planned over time, and the actual sales are also shown. There's 3 effects there. First of all, the overall sales, the overall volume, the overall revenue is lower. Maybe you sell a little bit longer with this type, but bottom line, it's longer. More serious is the slower ramp up. Our sales organizations don't believe us anymore. So their attitude becomes wait and see. And last but not least, the margins go lower, like in the HP case, as time progresses. So we have a big problem. So our objectives were and are, first of all, to improve this schedule reliability, regain the trust from our sales forces, also to improve the throughput, get more projects done in our organization, but also get the productivity up of the individual projects. And as said, we believe that in the long run, the largest gains will be in those fuzzy front ends. Realizations involvement started in August 2004. And the first project went live in December 2004. This was a running project, and a very large one, and a very complex one. The second large project went live in January in Lancaster, Pennsylvania. Also an existing big program that was slightly rescheduled and brought into Concerto. From then on, all new projects are running in Concerto. We had some serious issues during spring because we were not seeing the results yet. Too many of the projects, or the software mini projects, were running in red. We figured out that the root cause was in task management. We got additional support from realization and really worked on task management and the supporting processes. We are completing that. We start looking now at the multi-project environment. Today the focus was on the individual projects. And if we are successful, if we can show the tangible results, then we will roll it out to the other sites as well. Results is not just measured, it's also the perception of our internal customers, of our business management. Do they feel that we are more accurate, more productive, that things are running smoother? Achievements. Well, we have the mechanics in place. Daily Concerto updates are largely done. There's still islands where you have to push, where you have to reinforce, but mostly it's done. And it has led to an increased visibility in the actual status of the projects and a rapid identification of the problem areas. So that we achieved. Basic processes are in place and are also continuously improving. It's the daily task management, it's the network planning, it's an adopted project meeting structure. So that's run. We have established now continuous training and coaching of the task managers. We see an emerging task management culture where they have fun in it, where the cross-fertilization starts running. And the buy-in of the task managers is present and rapidly increasing. We also married CCPM with some of the agile development methods out of the software world, like Scrum. So the way we implement the task manager is similar to the Scrum Master. There's daily task management meetings modeled against the daily Scrum meetings. It's important if there's multiple initiatives that you marry them, that they don't run in parallel. We gained insights about what are the true constrained resources. And those are not the engineers. Those are, for example, in the early phases of the project, the system architects. They really slow down. They don't take decisions. No, we need to work this out in more detail. No, we have to look at another alternative. But the engineers can't implement. Also, purchasing. When there's a lot of tooled parts, you have to deal with multiple suppliers, and they're in China all over the place. They can become the bottleneck when there's 60, 70 tooled parts. We also get insights in the various sources of interrupts and Parkinson's law. It was funny, the realization guys told us, you know, there's at least 20-25% waste. So I made this calculation. What is my budget? How many million euros am I wasting every year? My boss will be happy. And initially you don't believe it, or you don't want to believe it, then you start seeing the first real examples, the tangible ones, and then you hit a wall. You don't recognize them anymore. Now we are past that. We really see the sources of interrupts of Parkinson's law. And we have learned the downsides of batching in schedules, what we were typically doing. Doing a lot in parallel and then big bang bringing it all together. We run mini software projects. So within a large project, let's say the hardware side is the so-called backbone, and then a lot of software mini projects feed into that. And they get launched when the resources are available. So basically that's pipelining within a large program. We have identified recently so-called senior task managers per discipline. Task management is more or less the same for all disciplines, but there are specifics in software, in electrical board design, in mechanical engineering, etc. So we want to establish a continuous learning environment, and you need the senior ones who teach. And we have realized the buy-in from the various stakeholders. My bosses, they approved it, and they are very interested. Sufficient key people within engineering, and also some important product managers that in our organization, let's say the commercial guys, marketing, the customers. Yeah? Buy-in needs to be continued. If we don't show up the results, this will be an issue, of course. We did very active benchmarking during the selection phase before we embarked with realization and concerto. That was very helpful. We started an internal survey. I heard that before this morning. And again, we have a clear understanding of the relationship between critical chain project management and this capability maturity model integrated. In our BOSCH company, it's something that comes top down. Thou shalt adhere to. So we don't want to run it as something completely parallel that is taking away resources. We want to understand how it fits together. And here some things are shown there. In particular, I want to highlight the last bullet. In CMMI, risk management is a so-called process area that gets specific attention. And we think this is very important in combination with critical chain. You have to manage your risks very well. When a task is in the green, it can still be a very important one because it's a high risk one. So it could easily turn red. You want to be proactive there. Challenges. Critical chain is really a major paradigm shift, certainly, or at least in our engineering organization. It's a culture shock. It really is. People have these deeply rooted behaviors and beliefs. Interrupts happen. They are part of life and you can't manage them. When the factory is calling, we have to drop our work and help the factory. When something fails, we have to repair that first. When my boss comes in, I have to answer him first, etc., etc. We have to challenge the assumptions. We have to learn them that they don't take things for granted. Development is uncertain by definition. It gets done when it gets done. We call that country club type of behavior. Yeah? That's not acceptable if you want to drive this. Yeah? So you have to teach them to develop aggressive recovery plans. Also, the deeply rooted behavior that your own estimates are so important, that they must be accurate, that you commit to them. Actually, that is what we taught them in the past. But it is, as you know, on fast execution and not on the individual task due date. And you also have to distinguish the true uncertainty from preventable issues that you can solve proactively and where risk management comes in. Another challenge was the fear for all kinds of side effects, micromanagement or the sweatshop type of fear that people would run in continuous overtime. You really have to overcome that. The task management role was completely new. It didn't fit in our current organization and functions. So it requires a very clear role description, very good training, but also continuous coaching. And buy-in of the task participants. What is this guy doing every day, asking me how many days to go, and etc. Discipline to keep Concerto up to date at all times. Sometimes still a challenge. So it's not only the time left, it's also the model, the task, the dependencies. They may change as priorities change. Furthermore, a large project, you don't plan it out in detail from the very start. It's a rolling wave of detail, but people have to do that. You want your task managers and your program managers to use Concerto as an execution tool and not just as a timekeeping tool. And we really have to force that and continuously challenge them there. Another cultural aspect is we find with engineers, they don't like closing activities. In fact, for most engineers, their activities are only closed when the product is released. Yeah? Then they are 100% sure that everything is okay. Yeah? But you have to force it. It's a mindset. So conclusions. Despite the fact that we cannot show these fantastic results yet, we believe that critical chain project management and TUC will bring it to us, both in schedule reliability and in productivity. It is not the single silver bullet though. It's a key piece in this challenging project management puzzle in a high-tech environment. But there's more you have to do. CCPM Concerto is not just another tool. It's a paradigm shift that requires time, commitment, and persistence from stakeholders. From the very top, throughout the layers, you need the stakeholders in your organization.